Hi, David. Can't wait to see. Hi, Madison. Long time no see. This is 7th. You're in the right place. And it's Dimitri. Jeremiah, cool. I'm glad you guys are awake. Dimitri, your sister, was saying how she likes to sleep till noon. Noon? I'll sleep to noon if I have a fever. That's about it. Oh, Katana's back? No, this is, what time is it? This is 12. This is for 6th. So if you missed the 7th, it's already recorded. It's already online. You can go back and look at it. Yeah, my apologies. This is for 6th. I'm glad to see you're awake, Madison. This must be your wake-up time. All right. Hi, Lucas. All right, so for some of you that were here on Tuesday, this is going to be a little bit of review. I found a really cool website with some stuff on it, but I'm having trouble with some technical issues. I will be getting the stuff posted. By the way, I'm scratching. I got into the poison ivy last week, and I've been pretty miserable. And I apologize for sitting there scratching. But got it on my arms, really there. That's itchy as can be, and on my legs. There'll be some, keep looking at Google Classroom. If you're in 7th grade, there'll be stuff posted. I will tell you that you need to enable the flash drive to do the lab. I actually have a lab posted on there. And Harold's watching over us, making sure we're doing a good job today. Wanted to show you that I do have my my iPhone with me today. Yeah, this is my iPhone. That's what you can afford on a teacher's salary, is an iPhone. Okay, so, and let's get started because let me first look and see participants. Okay, I can see everybody that's here. All right, good. That includes myself. By the way, Mr. Fosnight told me he wasn't feeling good. And so we probably won't see him right away. But we are talking about physical versus chemical changes. This is for the 6th grade. And so let me ask you something, and I'm going to start off by doing something really kind of silly. Got a piece of paper, okay? I've ripped it in half. Now, have I changed this physically or have I changed it chemically? Somebody answer. Is that a physical change or a chemical change? Physical or chemical? It's physical, right? I'm not. Now, what if I decided that I wanted to burn this, which I'm not going to do in my house? That's right, guys. It's a physical change. I physically changed it. I keep ripping it into smaller pieces. Okay, so if I decide to burn that, then what actually happens when you're burning something? It actually is, if you burn it, then it becomes a chemical change. So when we talk about evidence of a chemical change, right? When we burn something, what are some of the results of when we burn something? I could think of 3 things right off the bat. Think about your senses, what you see, what you hear, what you smell, what you could taste. Yeah, it's definitely a chemical. That's right, Lucas. If I lit this on fire, it would definitely be a chemical change. Okay, so we would see the fire, right? So we would see that fire. What we actually are seeing is what? It's light. And so that's one of the things that we talk about in a chemical change. One of the physical things that we would possibly see is light being given off. You're right. You could smell the smoke. Okay. And so that smoke is actually the product of you burning it. When you have 2 chemicals that are reactants, you end up with a product, and the product of that is the smoke, which is, anybody know what it mostly is? And is there a change of state? Yeah. What does this become? You can hear crackling, possibly. Certainly, if we were burning wood, we could hear crackling, maybe even some hissing if it's wet. We're left with ashes, right? And so after the fire burns out, we're left with ashes, and whatever goes up into the atmosphere, which is basically, for the most part, CO2, carbon dioxide. Okay, that's definitely a chemical change. That's a real obvious one. But taking the paper and actually ripping it in half, that's just a physical change. So light is giving off. You could smell it. A gas is produced. That's the CO2. What's left, there is a change in color with what's left. Can you actually taste it? If you get a mouthful of smoke, yeah, you could actually probably taste it a little bit too. Not going to be very good. All right. So I'm just going to spend a lot of time giving you guys examples for you to look at. Now, I do a lot of work around my house. Can anybody tell me what color those screws are that I have in my hand? Might be hard with that camera. Silver and gold. Yeah, I would say this one's pretty close to gold. This is like just more of like a tan or a yellow, and this one's green. That one's kind of a bluish green. Okay. These are actually exterior screws that are designed to be used outside, and they have inhibitors on there that keeps them from something happening to this and to these screws. And this is what actually happens to a screw like that that's been outside for a long time. Did anybody describe that? What's actually going on there? I'm trying to block the light. Yeah, it's rust. Okay. This is actually rusted. What used to look like a normal screw, which was probably more, it probably looked more like that, which is just a shiny metal. And now it looks like that. There's the difference between a new screw and an old rusty screw. Okay. So do you think that is a physical change or a chemical change? Physical or chemical? Physical or chemical change? It's definitely, good answer. It's definitely a chemical change. The process is called, I got to have the cursor in the right place. The process is called oxidation. Okay. And so it is the mixture of oxygen. Good answer, chemical. I got some good answers there. That's right. It's the mixture of oxygen with a metal. So you have O2 mixing with some form of iron, which is Fe, and you end up with a rusty screw. Eventually, this is going to rust so much that it'll break really easy. It'll actually deteriorate to a point where it'll start to cease to exist. These, on the other hand, are coated with a special coating, and they'll last much longer. They still eventually will rust, but they'll last much longer. All right. Here's one. Let's see. What we have here is a little bit of Kool-Aid. Now you can smell Kool-Aid. It smells a little bit sweet. So this is kind of a trick question, because there is another category that says neither. Something that's not a physical change, or here, can you smell it? All right, so this is not a physical or chemical change. This is, like I said, a little bit of a trick question. This is simply a mixture, okay, where the sugar and the water and the colorant that's in there, they actually they mix, but they can be separated. Okay. Oh, that's sweet. All right. So sometimes things can be classified as just, yeah, I know how to spell, just a mixture and not a chemical or physical change. And so that's important to know. We have to look for a change in color. We added orange to a clear liquid and sugar. Did it change colors? No. It stayed the orange. If it had changed colors to a different color, we might have thought that that was a chemical change. When we mix it together, is there a difference in temperature? No. Is any light given off? No. Is any gas produced? No. Is there a change in smell? Not does it have an odor, because everything has an odor. Is there a change in smell? No. Is there a change in taste? No. Why do I say no? Because it still tastes like sugar. It still tastes like water and sugar and the Kool-Aid mix. It's just mixed together. It's a little bit tougher of a concept to think about, but we've actually done an experiment where we have attempted to filter out the color. And so what do you mean about bees? And I'm not sure what you mean about bees, but I want to know what you're thinking. While you're typing that, I'm going to talk about something else. Water. I took some water from this bottle and I put it in this graduated cylinder. Excuse me. Is it still H2O? Yeah. Got my hand sanitizer. It's still H2O. Did it change shapes? I guess you could say it changed shapes, right? This is in a big fat bottle. Now it's in a little narrow tube. So we changed the shape of it, but it's still H2O. Let me put that over there. Put that over there. All right, what about this? I better show you this before I wait too long. Anybody know what these are? I'm going to be eating a lot of these over the summer. When you're working out in the yard on a hot summer day, it's awesome to be able to open up one of these. Yeah, one of these little freeze pops, the little popsicles. Okay. When I took this out of the freezer 10 minutes ago, it was solid. Now it's starting to soften up a little bit. Okay. Change, is that a physical change or a chemical change? That one should be pretty easy. And yeah, these are good. Bees are awesome. Bees are very important. One of the things a lot of people don't know is that other insects can be pollinators too. There's a lot of insects that are pollinators, including butterflies, and even flies. Anyways, no one's answered yet. Mosquitoes. I'm not very friendly with mosquitoes. Is this a physical or chemical change? All right. What about this deliciously rotting banana? This banana. All right. What's happening to this banana? Physical, chemical. Physical, chemical. Somebody answer me. Chemical for both. So this is, what about the banana? Banana, physical or chemical? Somebody answer me. We talked about an ice cube. Banana is chemical. This is chemical, right? This is, believe it or not, the same process that is happening with this rusty nail is happening with this banana. It's a process called oxidation, and oxygen is acting upon it, and it's starting to decay. The further we get along with this, it will get pretty bad, and we won't be able to eat it. And bugs, not only will it decay because of the, you don't want a rusty banana. Actually, this is probably still good to eat inside. But if I take that banana out and leave it sitting out, what's going to happen to that? So, and that's a rhetorical question that you should know the answer to it. If I cut the grass, which I've already done this year, I cut that grass, that blade gets cut in half. Is that a physical change or a chemical change? It's really just a physical change. I've just cut it in two, just like ripping that paper. If I have a piece of glass that I accidentally break, if I drop a bottle or break a piece of glass, or if I'm out in the backyard playing baseball and I accidentally hit the ball through a window in the garage, I've broken that glass. I've caused a physical change, but not a chemical change. What will we have to do to chemicals? What will we have to do to glass to change its state? We either have to heat it up or cool it down. So those are physical. And so this is really what we're talking about right now. And differentiating between physical changes and chemical changes. I have something, but I don't have it with me. When you take a piece of bread and you put it in the toaster, what happens to it? Yeah, you got to melt it. That's right. What happens with the glass? You would have to heat it up to melt it. What happens to a piece of toast when we put it in the toaster oven? What happens to it? What does it look like? How would you describe it? Or one of the things that I was really planning on doing with you guys is we were going to start a compost pile outside. Compost pile is where we take leaves, fruits and vegetables that are rotten, that we throw in there, so that we throw in a pile and we let it decay, and it becomes actually really good fertilizer. Yeah, so when we put the bread in the toaster, it cooks, right? And so how does it look when it comes out? It's actually brown and a lot harder than when we started off with. That is actually considered a chemical change because we've heated it up, right? And it's darker than what we started out with. When we put stuff into a compost pile, see, here's what the plan was. Compost pile, 6th graders. We are going to build a compost pile. When you got into 7th grade, we're going to do this at school. You got to use your compost as fertilizer and new soil in the garden. 7th graders, you get to plant your garden. When you come back from summer break and you're now 8th graders, we get to eat the stuff that's in the garden. It's a real cool process that all 3 grades get to be involved in. But this stupid virus had to come along and ruin things for us. So remember, when you have chemical reactions, remember everything is made of atoms and matter. And when you have a chemical reaction, the atoms are coming together and they're regrouping. And so you might have, when you have vinegar and baking soda come together, for example, it releases carbon dioxide, which is different than what you started with. It takes the carbon from one and oxygen from the other and releases it as a gas. And so you have a rearranging of the atoms that are in these things. Change of state is merely changing how it is, what it looks like. That big piece of paper into a small paper, freezing something or heating it up. I'm gonna have to eat this when I get off with you guys. Okay, so I really truly am gonna work hard on this today and get it posted for you guys. I have to download an app that'll allow me to break assignments apart because I'm trying not to assign you this big, huge assignment. By the way, tomorrow is pickup day for packets. So if you can get to school, great. Got nice big fat packets for you guys to do because we love you so much and want your brains to be filled with knowledge. And so those will be there for you guys to pick up for each grade, 6th, 7th, and 8th. Any questions right now? You probably don't have any. Make sure you've gotten all your old work done. Make sure you're telling your friends. There's still students that I have not seen log on or turn anything in. And I know those are some people that you guys communicate with. And I still haven't seen assignments from some kids. So if you guys don't have any questions, Hopefully, we cleared up some things a little bit about the difference between physical and chemical reactions. And just remember, what we end up with a chemical reaction is called a product. It's something different. Just like in math, when you add, when you multiply things, you come up with a product. When you take two substances and mix and combine them, they produce something different. That's a product. All right. I didn't say that all too well. Anyways, I hope you guys are having a great day, even though it's kind of cold outside. And until next time, over and out. Say goodbye to Harold. Harold wants to say goodbye to you. His mouth is shut right now. But he wants to say goodbye to you anyways. And as soon as I get off, I'm going to eat this before this melts any farther. Don't be jealous. Bye, Harold. By the way, I was at school yesterday. I got to see a few people. I missed the rest of you. Dimitri, I got to see your dad in the grocery store. All right, take care, everyone.